Alrighty guys, this is a brief tutorial video reminding you and giving you a little bit more of an extension on linear inequalities. Alright, the first thing we're going to do is we are going to talk about a couple of the inequality symbols, what it means, and what you are actually graphing and what you did in the activity yesterday. So, a couple quick reviews. Alright, we have our inequality symbols. So we have this one here. These are our four inequality symbols, all right? They should look pretty familiar to you. The top one here is less than. Then we have less than or equal to. And we have greater than. And then greater than or equal to. All four of these are inequality symbols. All right. When we went over the discovery activity yesterday, we tried to figure out the difference between an equation and an inequality. So when we went through that and we had the difference between an equation and an inequality, we talked about graphing. All right. And the difference that we have between the equation and the inequality is as follows. For an equation, when we graph that, our solution set is going to be the amount of solutions on that line. So again, the equation, that means equal, right? And that has the equal sign. All right. And that, if we looked at a graph and we had, say, a line, all of my equations or things that make that true are going to be points on that line. So again, the solutions are points on the line. However, with inequalities, they are a little bit different, all right? With inequalities, inequalities are not equal, or they're not always equal. Right? An inequality, we have four symbols: greater than or equal to, less than, or less than or equal to. All right, and with inequalities, the solutions are points that are in the shaded regions. So for example, if I had a coordinate plane here, and this was my line again, in the shaded region, I would have various points This point here would be a solution. This point here, here. Even along the line, because it's a solid line, those have solutions. So again, for inequalities, we're going to have more solutions that make the inequality true. So remember, when we make an inequality true, it has to give us a true statement. Meaning maybe it says we get it down to 1 is less than 3. That is true. Maybe we get -2 is greater than -5. That is true. So now we're going to go over a few examples of just about solving inequalities. So make sure you write these down. Alrighty guys, example number 1. We have the equation, or the inequality, 3x plus 2 is less than x minus 4. So you solve it just like solving a regular equation. We want to get the variables on one side, my constants on the other. So the first thing I'm going to do is I'm going to subtract x from both sides. That eliminates the x on the right hand side, and 3x minus x is 2x. So I have 2x plus 2 is less than -4. Then I'm going to subtract 2 from both sides, so that I now have my variables, my 2x on the left-hand side and -6 on the right-hand side. So again, my variables on the left, constants on the right. The last thing I need to do is I need to divide by my coefficient. And so I get x is less than -3. So what this solution tells me is any point where x is less than -3, I have a true solution. So in those values for x, I could put numbers like -5, -7, or even a ridiculous number like -123. All right, all of those values are less than -3, meaning they are further away from 0. So that is solving with just one variable in there. So let's look at another example. Example number 2 goes a step further. We have -3a plus 6 is greater than 18. All right, so here, again, we are solving the same way we would if there was an equal sign there. I want my variables on one side, my constant on the other, so I'm going to move -6 from the left side to the right side. So I'm left with -3a is greater than +12, right? Because 18 minus 6 is a +12. However, I'm going to divide by a -3. That cancels out. So I have a, and then 12 divided by -3 is -4. However, this is an important step, and it's important to note. When you divide by a negative, or when you multiply by a negative, you reverse, or you could say flip, the inequality symbol. So in this case here, it was a greater than symbol, so I need to flip it to a less than symbol. So my solution is a is less than -4. All right, And if we wanted to check that, if you're confused on saying, okay, why does that work? Well, let's check and pick a value that's less than -4. So if we plug in maybe -5. So if we look up at this original equation, I'm going to plug in when a is equal to -5. So if we look there, we would have -3 times -5 plus 6 is greater than 18. And we're trying to see if that makes a true statement. -3 times -5 is 15. And 15 plus 6 is 21. 21 is greater than 18. That is true. So we know that we performed it correctly. So just like when you could check your solution with your solving for equations by plugging in a value, you can do the same thing for inequalities. All right, but let's look at what we're going to be doing. Since we are talking about graphing linear inequalities, let's look at an example that has two variables. All right, example number 3, guys. We have 2x plus 4y is less than or equal to 12. So again, here I want to get it so that I can graph it. So I'm trying to solve for y. So that means I need to move my x to the other side. So I have 4y is less than or equal to -2x plus 12. The last thing I'm trying to do is to get y by itself. So I'm going to divide everything by 4. So then those cancel out here, and I'm left with y is less than or equal to -2/4x plus 3. However, I can simplify this fraction, my slope, right? And so I'm going to simplify that. So the simplest version I can get is y is less than or equal to -1/2 x plus 3. And just like we solved before, this fraction is my slope. This value here is my y-intercept. And it is graphing just like when we did y is equal to mx plus b, only now we have an inequality. And if you remember from yesterday, whenever I have this symbol here, since it's less than, I'm shading under or shading below the line. And then, because it has the or equal to, it's going to be a solid line. So putting all of this information together, let's flip onto your half sheet of paper, all right, where it says the example, and we're going to go over the steps to graphing linear inequalities. Again, these first couple of examples were solving for linear inequalities. Now let's talk about graphing. All right, guys, so for graphing linear inequalities, there are 4 big steps, all right? The first step is you need to always solve for y, because we're trying to get it to be y is equal to mx plus b. However, it's a little bit different because we no longer have that equal sign, right? That is going to be one of my inequality symbols. So that symbol there might be a less than, might be less than or equal to, greater than, or greater than or equal to. So that is no longer an equation, but an inequality. Remember, equation has the word equal. Inequality, this word part here, in, means not. So not equal. So you're not going to have an equal sign there. So the first thing, again, you want to solve for y so that we get it into that familiar y is equal to mx plus b. But again, we don't have that equal sign. We have one of our inequality symbols. The second step that we have is we are going to plot the y-intercept. So again, these steps should be familiar because this is how we start graphing a line in slope-intercept form as well. So the third step, like we did when we were graphing lines, is we are going to use the slope to plot additional points. The fourth step is you have to decide is it a dotted or solid line. Remember, it is a dotted line. So again, it's a dotted line if you have just strictly less than or greater than, and it is a solid line if I have the or equal to's. So that would be less than or equal to or greater than or equal to. The last step, which is always a special one to remember, is you have to remember to shade. And if we remember our shading rules that we went over, all right, our shading rules here, if it is a greater than or equal to, we're shading above. If it is a less than or equal to, we are shading below. So again, those are our shading rules, all right, up, above. So now we're going to go through an example on graphing the linear inequalities. So look at the bottom of this picture for me. So in this example, 2x minus 3y is less than 12. We need to go through and we need to follow our 5 steps. So the first step is to get it to solve for y. So when we go through here, we're going to subtract 2x from both sides. And I'm left with negative 3y is less than negative 2x plus 12. I now need to divide by my coefficient, so I'm dividing everything by negative 3. Because I'm dividing by a negative, remember I have to reverse my inequality symbol. So instead of being less than, it becomes greater than. And then I simplify. Negative 3 divided by a negative 3 is y. Negative 2 divided by a negative 3 is just 2 over 3. And then positive 12 divided by a negative 3 is negative 4. So my equation is y is greater than 2 over 3x minus 4. So now I have to go through and I have to look at some different things. Remember, this 2 over 3 is my slope. That's saying I'm going up 2 units and to the right 3 units. This negative 4 is telling me that my y-intercept is at the point 0, comma, negative 4. So that means I have to plot that y-intercept. So for number 2, I have to go down 4 units. 1, 2, 3, 4. Let's see if I can zoom in here to the graph a little bit more. So again, you're going down 4 units and plotting your points. 1, 2, 3, 4. That is your y-intercept, okay? And then you're using your slope to plot additional points. So I'm going up 2 units and to the right 3 units. Or remember, we can also flip that direction and go down 2 units and to the left 3 units to continue this line. So now that we have our points, we have to figure out if it is a dotted or a solid line. So if we zoom back out here, and we look, is it going to be a solid or a dotted or a dashed line? Okay, dotted or dashed, similar things. Okay, so dashed also could be dotted. All right, and if we look at our inequality symbol for our equation, we have a strictly greater than symbol. So strictly greater than means it is going to be a dashed line because we have the greater than symbol. So remember, our solid line is going to be greater than or equal to, or less than or equal to. Dashed line is just the strict inequalities. And then if we shade above, that is going to be greater than or equal to. And to shade below, remember that is less than or equal to. So again, we are going to have a dashed or a dotted line. Through your points. Say it's not like a smart board. I don't have a crazy straight ruler that I can use on this application, unfortunately. All right, so my line's not super straight. However, now we have to figure out our shading. So if we look, this was my inequality symbol, so I'm going to shade above. So that means all of this green shaded area is my solution set. All right, so the reason, remember, why we shade is to show the answer. For inequalities, you are not bound to just that line. You're going to have an area or a region. You are going to have more answers than just an equation. So if we looked here and tried to check our answer, and we picked a point, maybe we pick the point here. Let's do the point 1, 1. So if I was checking my answer for this, what I would do is I would have my original equation, right? Y is greater than 2/3 x minus 4. And I'm going to plug in 1 for my x and 1 for my y. And then I'm going to make sure that this gives me a true statement. So on the left, that's already simplified. 2/3 times 1 is just 2/3. And then I have 2/3 minus 4. All right, 2/3 minus 4 gives me -3 and 1/3. And that is a true statement. 1 is greater than -3 and 1/3. So that means that that point, 1, 1, is a part of the solution set. So again, you can always check your answers, check your graph, by picking a point in the shaded region. Then you plug those values in, you substitute in your x value and your y value, and you see if you get a true statement. So again, this was just a quick review, a quick recap on what we were doing, summarizing and extending a little bit off of the activity yesterday. If you still have some questions, please make sure you ask them, and then go ahead and work on your homework activity.